So good afternoon and welcome to the online module for data analysis for biomedicine using SigmaPlot. And in this week's video, we'll look at the content very briefly and I'll answer any questions that you have. So if you do have any questions and you're watching via Google Hangouts, then feel free to submit questions to me and I'll answer them. Otherwise, I'll just give you an overview of the material that we have, and then we'll take a brief look at the material in the week ahead. So if you have attempted this week's material, you'll notice that it's now more challenging than in previous weeks. And we are looking at how to analyze data using a two-way ANOVA or a two-way repeated measures ANOVA. So again, if you haven't looked at the material, don't panic, because the videos in this module will show you how to recognize when to use those tests and then how to enter the data, analyze the data, and interpret the data. Okay, so what I'm going to do is I'm going to share my computer screen so you can see the web interface itself. So let's go across that now. That didn't quite work, so let's try that again. So that's kind of strange. That's not working. Let's do that one more time. Let's just try this one more time. I beg your pardon. For some reason, it's not sharing the. Right, let's try this again. What happens if I drag that across? Okay, that's much better. So when you land in Keats, what you're looking for is data analysis for biomedicine using SigmaPlot, and you double click there and you get the landing page. And if you scroll down, you'll get to week 5, which is where we're at, which is the other analysis of variance tests. And this will include the two-way ANOVA, the two-way repeated measures ANOVA, and then the one-way repeated measures ANOVA. So click there to go through the content, and this is your table of contents. So let's look first of all at an experimental design for the one-way analysis of variance. So in this panel, you learn about an experimental design where there are 5 Petri dishes containing neuronal cells. And the experimenter is interested to know how much the cells secrete glutamate into the extracellular fluid under various conditions. And all the Petri dishes are treated the same way. So the scientist obtains 3 different samples per Petri dish in the following way. First, without treating the cultures, she takes a sample of medium from each dish and freezes the medium. Then all the cultures are treated with poly A, and 1 week later a sample is taken and frozen. And then the cultures are all treated with Syn C, and 1 week later a sample is taken and frozen. So all 3 samples per Petri dish are then analyzed for glutamate. And the scientist wants to know whether glutamate release is the same under all 3 conditions, or whether 1 or more of these 3 treatments enhances glutamate release. And so you should be able to see this is a repeated measures design. We have 5 Petri dishes that have a sample removed first with no treatment, then with treatment with poly A, then with treatment with Syn C. So each Petri dish undergoes 3 treatments. And you've measured the same thing repeatedly. So you've measured glutamate repeatedly from these 5 Petri dishes. So this is clearly a repeated measures design. And there's only one factor in this design, and that's the treatment. And so we're interested to know whether the treatment affects glutamate release. And you'll learn, if you use the advisor wizard, that there are 2 tests that would be suitable for this kind of data. And if you look up here, one of those tests is the one-way repeated measures ANOVA, and the other is the Friedman's one-way repeated measures ANOVA on ranks. And so in this short module, if you were to click here, you'll learn how to enter the data to run a one-way analysis, a one-way repeated measures ANOVA, and then how to plot the data, and then how to interpret it. And then you'll compare and contrast the one-way analysis, the one-way repeated measures ANOVA on ranks with the standard one-way repeated measures ANOVA. And you'll see whether or not you get the same results with each analysis. Okay, now we move on to the two-way analysis of variance. Okay, so in this previous page, what you'll see is the two-way analysis of variance is suitable for analyzing an experiment with two factors, each having two or more levels. So for example, that might be age and gender. And you use this where you measure the same thing just once in each subject. Okay, the two-way repeated measures analysis of variance is suitable for analyzing an experiment with two factors, each having two or more levels, and it's used where you measure this. It's used where you measure the same thing more than once in each subject. So this might be age and gender. Those might be the two factors, and you've measured the same thing repeatedly. And so we're going to see two different examples of each of these two different types of ANOVA. So if you click on page 11, we see an experimental design that one might use to one might use a two-way analysis of variance to analyze. So in this particular experiment, male and female rats were given either drug A or drug B, and the scientists measured how long it would take them to retrieve and eat a sugar pellet. So 12 rats were studied just once each, and the scientist is interested to know whether there's any difference between the genders in mean reaction time. The scientist is also interested to know whether one or other drug affects reaction time. So you should be able to see there are two factors in this experiment: the gender of the animals and the treatment, whether they got drug A or drug B. And it says very clearly 12 rats were studied once each. So this isn't a repeated measures design. Each animal was measured just once. So this would be suitable for analysis using a two-way analysis of variance because you have two factors and things weren't repeatedly measured. Each subject was only measured once. Okay, so then if you click up here, you can learn how to plot a histogram. And then if you click up here, you can learn to run and interpret the results of the two-way ANOVA. And I'll leave you to click on those videos and see how to do it. Now, let's see an experimental design for two-way repeated measures analysis of variance. So in this study, 12 mice are injected with either saline, diazepam, or amphetamine. So 4 mice receive saline, 4 mice receive amphetamine, and 4 mice receive diazepam. And each mouse is placed into an open field environment that contains 6 squares arranged 4 by 4. And locomotion is then assessed for 40 minutes, and this is done in 8 intervals of 5 minutes each. And the experimenter measures the number of squares that a mouse enters, and these are called crossings. So each mouse has its locomotion measured 8 times. So this is a repeated measures design. You've measured crossings 8 times in each mouse. And you should be able to see that there are two factors in this experiment. So there's the treatment, saline, diazepam, or amphetamine. So this factor has 3 levels, but there's also another factor, and this is time. So you've measured something 8 times, and that thing that you measured was crossings. So in this experiment, you could learn how crossings change over time, and you could learn how treatments affect crossings. So there are 2 factors: the treatment the animals received and the time at which you measured the crossing. So this would be suitable for a two-way repeated measures ANOVA analysis. And again, if you click here, you learn how to plot the histogram for this data. If you click here, you learn how to plot a line graph for this data. And if you click here, you learn how to run and analyze an experimental design, well, this particular experimental design. And so you might think this is all very familiar and easy, but the trickiest bit probably in this whole module is something called an interaction. And so when you have a factorial design like a two-way or a two-way repeated measures ANOVA, you can also study something called an interaction, and that takes a little more thinking about to understand. So when you get to page 18, you might find that you need to look at the content on this page a couple of times. So if you click on page 18, you'll find that there's a nice image here which is taken from a presentation by Dr. Aileen King, and she explains very nicely what an interaction is and what that means in plain English, and then how you would report an interaction from an experiment in a write-up if you have a manuscript. So I'd encourage you to work through this material, work through the exercises at your own pace, and become familiar with the one-way repeated measures ANOVA, the two-way ANOVA, and the two-way repeated measures ANOVA. So that's all that I'm going to comment on for this week's video. I'd encourage you all to continue persevering with this material. This is actually as hard as it gets. And then in week 6, what you'll find is how to analyze a different type of data, which is data measured in categories, and we're going to learn about the chi-square test. So if you struggle in this week's material, do persevere, but then don't be afraid to try week 6 material as well, because you'll find actually it's a lot easier than this week's material. So good luck with your studies, and I hope you find this this module useful in your understanding of statistics.